the hospital. At ICES, the electronic medical data are gathered from multiple sources to build up a huge data repository, which contains information for more than 6 million patients. This repository containing a wide range of data types, including demographic data, insurance information, and some etc. Altogether, the number of distinct variables in this dataset can easily exceed 100,000. Researchers hope to use this huge amount of data to retrospectively study the impact of different cancer interventions or cancer treatments. To do so, they have to first select a cohort of patients out from this over 6 million population. The selected cohort needed to be within smaller, manageable size, but yet still being representative of the overall population to be studied. And usually, this type of cohort selection work is accomplished by applying iteratively a series of inclusion or exclusion filters onto the datasets. Using traditional methods, the whole process can take up to months of efforts, involving a large number of complex customer-built SQL queries as well as statistical analysis. To support this cohort selection work, a visualization-based data selection system is built. We call it baseline system here in order to compare with the later extended version of system, which is adaptive contextualization. So the baseline system is developed with a similar design, similar to a prior work called decision flow. Both this system and the decision flow allow users to ad hoc explore on the high-dimensional temporal event data, which suits well for the medical data sources. Additionally, our baseline system here also allows users to interactively to apply filters, inclusion or exclusion onto the datasets. So this matches closely to the workflow that I introduced in our motivating example. The baseline system is composed of 4 major parts. First part is a visual query panel, which we use to retrieve an initial cohort. The second part is a breadcrumb panel, which shows a sequence of constraints added during the selection process, and as well as the resulted data sets. And the third panel is an interactive temporal event data visualization panel that supports direct manipulation for subgrouping the current cohort, and also for defining the new constraints. Those new constraints can have temporal sequences so that the users can specifically define some constraint of event happen after or before some other event. And the last part is also an interactive panel. It shows the future correlation visualization of demographic data as well as the procedural events data. So although with the direct manipulation as well as the visual query here, the cohort selection can be much faster and more intuitive. However, there still exists one problem. Even with the most advanced visualization technique, the number of dimensions that can be shown at the same time in the visualization is still very limited, much smaller compared to the number of the dimensions that exist in the original dataset. So due to this mismatch, users who perform data selection visually have a very narrow view of the datasets they are manipulating. And this becomes a serious problem when there are a lot of variables in the datasets that are highly interdependent on each other. And unfortunately, in the real-world dataset, they usually are, as indicated by the feature correlation visualization in our previous slide. So therefore, when users apply iteratively inclusion or exclusion criteria onto the datasets, some other variables in the dataset that may be highly associated with those criteria may also be affected in the resulting subsets of data. And due to the limitation on the number of dimensions that can be shown concurrently, the impact on those variables may be hidden from the user, and thus the selection bias is introduced in this process without the user's awareness. So to tackle this problem, we propose an approach called adaptive contextualization, which is an intelligent visualization technique that can monitor and model the user's visual data selection activity. It can compute the metric used to model to quantify the degree of selection bias introduced, and visually represents these computation results for contextual awareness. It also provides an interactive tool to help users assess the bias and to help them revert the problematic filters to explore alternative selections. Our work is related with several different areas in research, including high-dimensional visualization technique, intelligent visualization system development, and some provenance modeling used to capture and record the user's activity trails. For more details, please refer to our paper, and I'll skip this for time reason. So to give a more detailed description of our AC system, I'll first start with our provenance model. At the core of our AC system is a model designed to capture the provenance behind the current data sets being visualized. As shown in this figure, this provenance model is represented by a sequential chain of dataset DI linked by the filters Fi. Each filter Fi contains one or more constraints that's defined by the user's interaction with the visualization. And every time a new filter Fi is added to the model, the resulted dataset DI is also appended to the end of the chain. The last dataset, D-active, which is also D6 here in this figure, represents the current dataset being visualized. And if for any reason user is not satisfied with this current dataset, the reversion is supported in the model. In response to a reversion, the model first cuts back to the selected data point, for example, D1 here in this figure, and then extended along a new branch in response to the new filters. To represent this model in the user interface, the AC system extended the baseline system on the contextualized breadcrumb panel. So each dataset is represented by its own glyph. As users apply more and more filters to get new datasets, new glyphs are added from left to right in the panel. The last glyph, which represents the current dataset, is highlighted with a yellow border. And each glyph shows the size of the dataset with a number, also with a blue indicator whose height represents the size of the dataset as a fraction of the first one. When mousing over these glyphs, it will provide a list of applied filters to arrive this dataset. And another very important component in the glyph is the color part at the bottom of it. This color part represents the comparison metric we use to quantify the difference the selection bias introduced during the selection process. This comparison metric is built upon the Henninger distance, which is used to measure the similarity between two different probability distributions. The formula to compute the Henninger distance for two discrete probability distributions is shown here. And we first use it to compute the distribution of values observed for the same variable in the datasets. And then we define another multivariate metric, which is noted as delta here. So delta is a metric used to compute the weighted average Henninger distances across all the dimensions in the datasets. And in this formula, Vij and Vik are two probability distributions for the ith variable in the dataset, dj and dk. Wi is a weight assigned to the ith variable. It can either equals to 0 or to 1. Variables that have been explicitly constrained in the filter Fi before the datasets dj and dk in the model are all assigned to weight 0, while all the other variables in the dataset dj and dk are assigned to weight 1. In this way, this weight is used to ignore the distances that have been contributed by the filters that have been explicitly filtered out by the user. And both the Henninger distance and the delta metric here have a value vary from 0 to 1, with 0 means identical distribution and 1 means maximally different distribution. So each time when a new dataset is added to the model, some process runs to compute the variable distributions in the datasets and then compute the individual Henninger distances for each variable, as well as the later computation of the delta metric for the whole dataset. So this computation result is reflected on the color part, and we use a color scale from green to yellow to red to map this color part. So pure green means no bias exists, which equals to delta equals 0, and the larger the selection bias is, the more the color moves from the green end toward the red end. By clicking on any of the glyphs that other than the one representing the current dataset, there will be a dotted line show up, connecting between the two compared datasets. And with this selection, the balance panel in the user interface will get activated. This panel provides a detailed comparison for individual variables in the two datasets. On top of the panel is a list of constraints, and the bottom part shows users the detailed comparison between each variables in the datasets. And so this part is very critical for the user to help them understand what variables contributed the most to the delta metric, because those variables are ranked by their Henninger distances, so that the ones placed on the top are the ones that shifted the most in the two data sets. And here is a short video showing all the features that I described for our AC system. So we first use this visual query panel to retrieve an initial cohort of patients. Then we can add some demographic constraints to the current cohort to subgroup it. And we can add one of the subgroup to our cohort chain as a new data set. So here is a list of events happened during this time of period. And then we can add another new cohort. So mousing over the glyphs will show you the overall information of the data set. And now by clicking on one of the data sets, we are comparing the current one with the clicked one. So we are checking what variables shifted the most in the data sets. And now we can revert to the original data set. And some new selection can start from here. Okay, so to evaluate our system, we conducted a user study. And okay, I saw the timing. Maybe I'll skip the study part. So the results from the study shows that our system benefits users in assessing the selection bias during the high-dimensional data visualization and the selection. And we have several future works planned. Like we want to conduct several long-term case studies to further evaluate our system, and we also want to explore some intelligent ways to help people minimize the impact of the bias during the selection. And so that's it. Any questions?
Do we have a question for the audience? While you're thinking, I have a couple of questions. So very interesting work, and we really would like to play around with the system a bit. But one question is, given that there is another data set, not of cancer patients, but some other data set, how easy is it to transfer or replicate your system for this other data set, which is about something different?
You mean transfer it from one database to another one? Or?
Yeah, transfer your approach from cancer patients to some other type of data.
I mean, I think the general idea is like what it can be widely used for different specific situation. And if you are talking about like different patients, then I think what needs to be transferred is just to change like the query to make it adapt to different database or data structure. I don't know if that answers your question, but that's what I understand.
Thank you. And also, I noticed in the paper you used known experts for the evaluations.
Yes.
And I was interested to understand how did you form the tasks, thinking that these are known experts, because usually this type of data is used by highly trained medical professionals. So I was just interested to know, I mean, it's easier to work with non-experts because it's easier to find them, but what impact did this have on how you formed the task, and did you had some experts forming the task? Who did you collaborate with some experts?
So all three of our authors are not like really healthcare professionals, but we think that our system, because the purpose is to evaluate the selection bias during the data selection and randomization. So actually, we don't really think it requires very high professional medical knowledge or stuff like that to play with our system and to see if this can help you review the bias. So that's why we use non-expert users. And
Thank you, Shunshun. And there are no more questions, then we can thank you very much again.
thank you.
And here we continue with Multiconvis, a visual text analytics system for exploring a collection of online conversations.
HD, right?
And Emmanuel Hock will be presenting from University of British Columbia. And this is a long paper, so you have 17 minutes. If you need help.
Yeah, I was trying to find the HDMI cable. Okay, I need to. Thank you. So, hi everyone. I'm a PhD candidate from the University of British Columbia, and I'm going to present a visual text analytics system for exploring a collection of online conversations. So this work has been done in our NLP group at UBC with my supervisor Giuseppe Carinini. So as we all know that in the last few years, there have been tremendous growth of online conversations, and we talk to each other in different domains such as blogs, forums, and Facebook to communicate and to express our opinions. And if we look at the statistics of a particular domain, such as blogs, we can notice that there are 100 millions of blogs in the internet, and this audience is kept rising exponentially. And these conversations are scattered around different diverse set of text genres, such as politics, technology, and business. And the question is whether the existing interfaces for exploring these conversations are sufficient enough to support the task that the user would like to perform. So to answer this question, we can look at a particular problem scenario. So in September 2014, the iPhone 6 was released, and soon after that, some people claim that this new phone can easily bend in the pocket. So I'm wondering how many of you heard of this story of BendGate, where people talk about this bending issue? Yeah, quite some. So, you know, once this video was posted in YouTube, it went viral, and many people started talking about this bending issue. So this leads to a lot of discussions in MacRumors, which is a blog site for Apple-related news. And in this scenario, you could imagine a user, John, who is interested about buying iPhone 6 and would like to verify whether this bending issue is really serious or not. So if John would like to verify this issue in MacRumor, he would have to provide a query in MacRumors, which would produce a search result set like this. So in this search result, you could see for each conversation, you have the title, the number of comments, and the posting date, and so on. And if the user is further interested, so you can click on this conversation, which would open in a new tab or window of the browser, and then the user can sequentially go through all the comments of the conversation. Now the problem here is that if you notice here, there are 25 pages of comments for only this conversation. And there are multiple conversations about the iPhone bending issue in this search result set. So the user had to deal with thousands of comments about iPhone bending. And this could potentially lead to information about the problem where the user get overwhelmed with the amount of conversational data. Another issue here is that the user also needs to deal with different scales of granularity. So at the beginning, there are a lot of conversations that produced by the search query, but then the user needs to narrow down and explore the subset of conversations and eventually to the subset of comments of one conversation. Now, to deal with this problem, we try to integrate the natural language processing techniques with information visualization so that the user can be better supported in exploring the set of conversations. Now, we have been working on this problem for quite some time now, and previously we have designed a visual interface for exploring one conversation. And if you were in the previous IOI conference, you may remember that I present this interface where the user can explore one conversation. So within this interface, we provide a visual overview of the whole conversation, where for each comment we represent a stack bar where the purple indicates highly negative sentiment, the orange indicates highly positive, and then around this thread overview we have the set of topics and authors which are connected to these comments using curved links so that the user can get the relationship between topics, authors, and comments. And then finally in the right we have this detailed view which shows the list of comments. Now, as we move from exploring just one conversation to the set of conversations about a related query, then two important challenges emerge that we need to deal with. The first challenge is that now that we have moved from one conversation to a set of conversations, the number of topics that the user needs to explore grow exponentially. So to deal with this problem, we organize the set of similar topics into a hierarchy. The second problem is that in the previous interface, there was just one conversation, but now the user needs to deal with a set of conversations to a subset of conversations, and then finally to set of comments for which we need to design a way to switch between these different granularity. So to deal with this problem, we have designed this visual interface where you can see that in the left, the topics from different conversations about a query is organized into a hierarchy. And then in the right, the set of conversations are presented as a list. So we'll go over this interface in more details later on, but the high-level overview of this work is that we presented a hierarchical topic modeling approach that organized the set of topics from different conversations. We design an interface that helps the user to switch between different levels of granularity of conversation. And then finally, the evolution of the interface, which helps us to understand the potential strength and weakness of the interface that we have designed. So first, we want to discuss about the hierarchical topic modeling approach. So previously, we have adopted a topic modeling method that generates the topics for each conversation. And these topics are generated by taking advantage of the conversational features into account, such as the reply relationship between comments. Now, one could imagine when we generate the topic hierarchy, a top-down approach could be more appropriate. However, given the fact that we need to take advantage of these conversational features in order to improve the accuracy of the topic model, we decided to design it using a bottom-up approach. So we first generate the topics for each conversation, and then we clustered this set of topics into a hierarchy. So I'm going to talk about how we generate the topic hierarchy from the set of topics. So for this purpose, we create a undirected weighted graph. And then within this graph, you can see this toy example where each blue circle represents a topic from a conversation. And then the white circle within that blue circle represents the set of sentences for that topic. Okay? So the next step is to measure the similarity between these two topics. So for this purpose, we measure the similarity of two sentences between two topics. So basically, we compute the similarity for all possible pairs of sentences between two topics. And that similarity is measured based on either cosine similarity, if these two sentences are coming from different conversation, or based on the conversational feature, if they come from the same conversation. And then we just take the average to measure the similarity between two topics. And then in the next step, we applied the graph-based clustering technique, where we applied the normalized cut criteria. So this results in the set of clusters, as you can see here. The structural parts and the smaller iPhone are two similar topics. That's why they are grouped together. And then we generate the topic labels for each cluster. So the idea is to take all the sentences for this topic and then apply a syntactic filter to choose only nouns and adjectives, and then rank these words to pick only top few words and create the phrases. So that's how we generate the topic hierarchy. Now I'm going to talk about how we design the visual interface. So the main challenges of the visual interface design was what data we want to show to the users at different levels of granularity, given the screen space limitation that we have. So to decide which data we want to show to the user, we started by analyzing the user requirements, by asking this question, why and how people actually explore the set of conversations. So when we analyzed why people explore the conversation, we found that the users typically read online conversations, that is blogs, to seek information and opinion about their topics of interest. And they also would like to understand the when aspect, like, for instance, when iPhone bending went viral, when there were more positive versus negative opinion about it, and so on. And sometimes people explore conversation just for fun and enjoyment. So from this analysis, we decided to use topics, sentiments, and time as some of the primary dimensions of the data that we would like to visualize. Then we also analyze how people explore conversations to get a more sense of the kind of granularity level that they need to deal with. So we found that the users are quite variety seeker. They skim through the conversations, and they tend to switch between different levels of granularity from the set of conversations, then narrow down to the subset of conversations to the set of comments. So from here, we abstract the data to finalize what data we want to visualize. So you can see each row here represents a data dimension, such as topics, time, and sentiment, and then each column represents the granularity level, that is the set of conversation versus one conversation. So you could see that when we represent one conversation, we can show more detailed information in the screen. However, when we show the set of conversation, we cannot show all the detailed information. So we abstract the data and we aggregate the data. For instance, instead of showing the list of topics, we organized the set of topics into a hierarchy and collapsed the children topics. Then when you show the sentiment distribution for each comment, in case of set of conversation, we show the distribution for conversation as opposed to for one comment, because we now need to aggregate the data. So once we abstract the data, in the next step, we iteratively design and redesign the prototype, and this is the final interface that came up with. So as you could see in the interface, in the left, we have the topic hierarchy, which organizes the set of topics from different conversations. And in the right, we have the conversation list. And you could see that on the top, there is a timeline, which shows the volume of comments over time. And within the topic hierarchy, the nodes are organized using an indented tree representation, because this allows us to provide a more compact representation so that we can show at least 50 nodes without requiring vertical scrolling. So for each conversation, we show some of the metadata that traditional interface shows, but then in addition to that, we show the visual representation of the sentiment distribution, as well as the volume of comments over time, as well as the count of topics and authors. This visual representation helps the user to narrow down, to find the interesting set of conversations from the set of conversations. So this kind of serves as the information sent to the user. So now I'm going to show a quick video demo to illustrate how the interface works. Okay. So as you can see in the interface, the user can start by selecting a time range from the timeline, which reduce the set of conversations to a subset. And then the user can start exploring by hovering on a particular topic and expanding the topic of interest, which expanded into the children nodes. And then the user can explore the topics and click on a particular topic, which immediately highlights the corresponding set of conversations. Then the user can keep on exploring this set of conversation by clicking on this timeline view, which shows the sentiment distribution over time. So the user can see, like at the beginning, there were more negative versus later on positive. And then the user can zoom into a particular conversation, which shows the results into the Convis view. So now the user can explore individual conversation by hovering and clicking on different topics of that particular conversation. And then she can click on particular comments by clicking in the thread view. So this corresponds to the detailed comments that the user can notice. Then the user can click on a topic, which will take her to the list of conversation. Okay, so that's a very quick overview of how the interface works. So now I'm going to talk about the evolution that we have done. So we performed two different kind of studies. One was a case studies with 3 different type of users. One was a regular blog reader, another was a journalist, and another was a business analyst. And we provided the data set that were interesting to them. For instance, the journalist explored the data set on Obamacare health policy, whereas the business analyst explored the data set on iWatch release. And we also performed the follow-up interviews where we understand their opinions about the visual interface. We found that they use the interfaces quite differently. However, all of them agreed that the topic hierarchy was useful for the task that they wanted to perform. And then we also performed a laboratory-based study where we compared this interface with a standard interface. And the task that we provided was to explore this set of conversations. And then after the exploration, they would write a summary of the major key points that they found from this set of conversations. So you can see here we compared this interface with a traditional interface, and we have 16 subjects, and we design using a within subject design, and we vary the interface order to counterbalance any potential effect of exposure of interface. So we can see that in terms of the time to task completion, we haven't found really any significant differences. However, when it comes to subjective ratings, we found that there are some significant and interesting differences. For instance, we haven't found any differences in terms of ease of use, but we have found that the users found the multi-Convis interface to be more enjoyable, and they found the major comments, the major points, and the more insightful comments from the conversations. So when it comes to preference, we found that this interface was preferred by the majority of the participants, and the reasons that they explained was this topic hierarchy organization and the visual overview of the conversation helped them to choose this interface. When it comes to the traditional interface, those who choose this traditional interface mentioned that the simplicity of the traditional interface helped them to choose this interface. Also the fact that they were so much familiar with this standard interface that they opted for this interface. So in conclusion, we propose a hierarchical topic modeling approach that is designed based on bottom-up approach by considering the features of the conversation. We designed the multi-Convis interface, which helped the user to start with a set of conversations, then narrow down to a subset of conversation, to a set of comments of one conversation. And we evaluate our multi-Convis interface with traditional interface, and we assess the different interface features, which gives us some interesting insight. So in future, we would like to explore the possibility of interactive topic hierarchy revisions by the users, which would possibly help them to modify the topic hierarchy to fulfill their information needs in a better way. And we would also like to investigate whether this visualization can be helpful for some specific conversational genres, such as community question answering forums. And we would also like to deploy our system and test in online to figure out whether in a real world scenario, whether the users would really benefited from this system. And this would also give more ecological validity of our approach. So with that, I would like to conclude my talk. I would like to hear your questions, and thank you very much for your attention.
Thank you, Anamul. So we have questions. One question is coming. Very good.
Hi, interesting work, thank you. I'm Anushka, I'm from Tableau Research. So you started out with this question of, you have a question about the bending iPhone, and you go to this forum and there's tons of conversations and you basically just want to know the answer. So you ended up with a visual tool that lets you summarize each conversation. And what I thought you were going to do is do this grouping, right? Overall, I just want to know, what is the answer? Is it positive? Is it negative? So how do you see taking your approach and kind of summarizing it instead of having a visual per conversation? Just tell me the summary of all of these conversations so I can only read like the summary. Does that make sense as a question?
Yeah, to some extent, yeah. So I guess, although for the spending issue problem, I guess the goal of the users were very specific, like to verify whether this spending issue is serious or not. Versus in other cases, the task could be like, for who is a business analyst would like to understand how to react to this situation of bending problem versus a journalist who just want to summarize to write a story about what people are saying about this bending issue. So I guess there could be multiple different scenarios that we might to deal with. And at this point, the interface is a bit more generic, which I guess do not directly answers to the specific scenario that use.
Right. But that was also your scenario that you tested, right?
Mhm.
You had the user, the journalist try to figure out Obama
Yeah.
healthcare. Is it positive or negative? Basically, the task you asked the user to
Yeah.
do was a summary task.
Yes.
And you showed them a view that didn't summarize. So I was just trying to see if you thought about bridging the gap there
Mm-hmm.
and whether the topic hierarchies were correlated with the key points that you asked them to identify.
Yeah, so at this point, so for instance, when we tested this particular use case scenario, we found that the user were first trying to identify some of the key topics from the topic hierarchy, such as like the bending issue, what Apple has to say about this issue, what customer care people are saying about this issue, and then going through deeper through those topics into the particular set of comments, as opposed to sequentially go through hundreds of comments. And then they very quickly find it out, for instance, that there is a particular process of creating these aluminum sheets, which helps them to be more rigorous than people thought. And he concluded that the iPhone bending is not as serious as people thought. So by going through those particular topics and immediately narrowing down to this set of comments of that particular topic, help them to understand, to verify the issue. So yeah, that to some extent helped. Yeah.
Thank you. Let's take one more question.
I wonder if you have a sense of what types of domains, sort of conversation domains, this approach lends itself to. I mean, we've probably all experienced situations where we've read comments and kind of come out maybe a little bit dumber than before we went in. And so are there certain, like I saw you studied a range, but are there certain types of content or discussions that sort of suit this approach a bit better?
So are you thinking about conversational genres such as like politics versus technology?
Yeah,
or
so I think technology is probably a really great application for this
Mhm.
this technique, because they're really nice factual discussions. I saw you had the Obamacare, but
Mhm.
I'm sort of interested in these more maybe emotional, opinion-oriented ones. If you have any ideas on where it works and where it doesn't work as well.
So the way it's currently the interface is designed is to deal with the conversations having highly opinionated. So as you can see in the interface, we have the distribution of sentiment, we have the sentiment over time. So I expect this to be more useful for highly opinionated set of conversations. Yeah,
Okay, thanks.
thanks.
Thank you very much. Let's thank again Namul. Thank you very much. So, and next to topic modeling of document metadata for visualizing collaborations over time. So not too far away from the last paper. And we have two presenters, Patrick Xu, who's just now setting up, and also Francine Chen will continue the presentation from FX Palo Alto. And I think Patrick is ready.
All right, that's good.
Did it work?
Yeah, it's just connection is loose. Okay.
All right. Yeah, good afternoon. I'm Patrick, and I'll give the first part of the talk, followed by Francine. So the problem that we're looking at is visualization of collaborations over time based on the analysis of bibliographic metadata. Some example uses are to find people with expertise in certain areas, or find people that have a broad range of interests across disciplines, or with recent experience or lots of experience over time. It can also help the management assess the balance of the people over the projects and see how the policies impact the team members over time. So a lot of the previous work focused on the theoretical properties of citation network graphs and more on the papers than the people, and also on single or limited venue of papers. As been pointed out before, some of the things that are visualized are not really that useful, such as the paper with the most citations or the author with the most publications, and things like degrees of separation. So some things that would be useful to visualize are the people along with the areas of expertise and also the temporal dynamics. So from the document metadata analysis, we want to know who is involved and what they worked on. For the relationships between the people, that can be deduced from the co-author information. So the question is how to determine the areas of interest. So one way is to, say, use the publication venues, but there are a couple of problems with this. One is basically scaling to larger number of data sets, or when your data set only has a single venue or a single area. Another way is to use the keyword, a simple keyword matching. And the problem here is that there are relatively few matches for a given keyword. So you end up having to use lots of keywords, and then that's going to make your visualization really busy. So what we propose is to use topic modeling. The topics from the topic modeling are more meaningful as areas of interest than the venues. And as a dimension reduction technique, it scales better than the venues and the keywords. The model that we use is the popular LDA model, it's probabilistic model. And it's computed, or we computed over the document metadata text, specifically from the title, keywords, and abstract. So the abstract will provide enough text to make this work. It has a vector space of terms that are given by the tokenized keywords, and the tokenized words and the cleaned up words. And there's a parameter k that specifies the number of topics. And what the topic model gives you, the LDA model, is a representation where each topic has a set of terms and associated probabilities. So you see example there on the left. There's a similarity measure, which is just based on the cosine function. And this allows us to lay out the topics using multi-dimensional scaling. It also allows us to filter out the people, to focus on the most relevant ones, and to reduce clutter. Okay, we also apply burst analysis to the topics using Kleinberg's algorithm. So for each topic, at each time point, there's a number of documents, and these will generate an activity stream. And then from the burst analysis, we get 4 levels of bursts, and these are mapped to 4 heat colors in the visualization. Okay, for the visualization, we use, it's a fairly simple node link graph. It has 2 kinds of nodes. The topic nodes, these are fixed, and they serve as references or landmarks in the visualization. And those are the square nodes in the picture. The top 3 terms from the LDA are shown, and then the user can enter a label. And there's a color that represents the burst level. The second type of nodes are the person nodes, and these are the round nodes. These are transient, and they move around based on the force-directed layout. Then there are links to the relevant topics and other people. So in conjunction with the node link graph, there's a time slider. So when the user selects a time interval, the person nodes will appear and disappear in the topic landscape with animation. So earlier we built a prototype that was demonstrated at CSCW. The major differences are that now we have the topic modeling and evaluation, and we also have built a desktop app that runs with a 4K monitor versus a web-based application. And there's more discussion-related work in the paper. So putting it all together, this shows the different modules and the flow. I just mentioned that we had to compute some intermediate data structures in order to make this run interactively in real time. And I'll show a video which kind of makes sense. This is based on our lab's publications over 21 years. Okay, so time sliders on the left, and as the user manipulates it, the nodes will come in and out of the visualization, and then they move around. Yeah, we can probably actually make this run a little bit faster, or tune it to. Then the next thing we show is to enter label. So when the user has domain knowledge, she can probably think up of a better or more descriptive label than what the LDA terms give you. So it's important to provide such functionality. And the user can click on the topic node, and then you get a pop-up window to enter the label. And with these node link graphs, sometimes there's some clutter, so the user can drag the node and see the node better, and then it bounces back. And one more thing to show you guys is the burst. On the upper right, you see a topic that's going to burst red and then not red. So that was a project, our lab, that was very active for a few years and then became less active and inactive. Okay. And this is just a close-up of the showing different things in the visualization. Okay, I'll just give one more example. This is from the public data set for InfoVis 2004 contest. Originally it was 8 years, we extended to 20 years. So on the bottom left panel, we see this person, John Daniel. He's working with 2 people on a topic. And then 2 years later, he's working with an additional person on another topic. And 7 years later, he's like completely moved to a different part of the topic landscape, working with different people and topics. So now hand over to Francine, I think. Okay.
So Patrick mentioned some of the data sets that we used. The first one's the InfoVis 2004 contest data, which is the metadata composed of papers plus references. But some of the contestants also looked at only the papers and not the references, which is what we did. And then we extended it to 20 years so that we could look at a larger data set and see how the visualization handles that. We also, since InfoVis is just one venue, we also looked at the publications from our laboratory over 21 years. And our laboratory is relatively diverse, and we publish at a lot of places. So this looks at a number of different venues. The first thing we want to do is we wanted to see, well, how do the keywords that we get from the LDA model compare to the other keyword sets? And if you look, we looked at the keywords that the contestants came up with, and they were pretty diverse. Some people used manual methods, other people used automatic methods, such as clustering, identifying high-frequency terms or bursts of high-frequency terms. And I've shown an example of 3 different keyword sets by the InfoVis contestants. And you can see that some of the terms are similar across the different keyword sets, but often they don't use exactly the same phrase. So the first thing we needed to look at was how can we handle that, because the normal way to represent words is as a term vector, where each element of the vector corresponds to one word. And what we did instead was we used the word-to-vec word embedding, which projects each of the terms down to a lower dimensional representation, so that words that are similar in meaning tend to be projected down into the same part of the space. And then we can use the cosine similarity measure to identify terms which are similar to each other. Next, now that we have a similarity measure, we want to compare the topic keyword sets. So for example, if on the top left, we have a keyword set of 5 terms that we call a reference, and then we want to compare it to another test keyword sets to see how the two match each other. We just simply compute for each of the reference key phrases, which of the test ones match the best using our similarity measure. And we select the maximum similarity as the score of that key phrase. And then we can average over all the reference key phrase scores to get a general score for the keyword set. And so this is across pairs of keywords. And what we do is we do that for all the different pairs that we have. And then we can compute a similarity matrix, which is shown on the lower right. And one thing that we can see is that there's several frequency-based methods. They're pointed out with the orange arrows, and they all seem to have pretty good similarity with each other. The set that seems to have the least similarity is clustering, a manual method, and LDA. They're not like the frequency. So that kind of makes sense, that they're different methods, so they come up with different topic sets. Now we can look and see, well, how do they, if we apply these different topic keyword sets, how similar are they to the document collection? If we match each document against, say, the best keyword in the keyword set, how good is it representing each of the documents? And in the graph, we can see on the left, in gold are the InfoVis keyword sets, and the 2 manually defined ones are shown in red, and they actually performed the worst. The automatic methods did better. Also, if we look at where the green arrows are, we're comparing on the left the similarity with the references, and on the right the similarity without the references. So that also makes sense, that not having the extra data from the references, if you don't have that, then the performance is poorer. Now, if we look at the LDA topics, which are in blue, where we computed LDA with different number of topics because the contestants all used different numbers of topics, so we did it for whatever the contestants used. And for each set number of topics, we had showed the n most probable terms, where we looked at 2, 3, and then finally 10. And if you look at 10, which is on the right of each set, we see that we have pretty good similarity, better similarity than any of the other keyword sets. So we think that provides support for our method of using the 10 most probable keywords to represent each topic in our visualizations. And we have a bunch of other results that are in the paper, but I'd like to highlight one that we thought was more interesting, which was, when do you get the higher level bursts? And we noticed that they occurred when there's a larger number of topics. The largest number of topics for both the InfoVis 20 and our lab data is shown on the right, and that's when the higher level, where it's the dark gold, or the orangey one, is a burst level of 2, and the red's a burst level of 3, and those are the highest levels of bursts. And we also see that we get more bursts, higher level bursts, when the content is more diverse, as in our lab data. So in conclusion, we looked at a method for where we could visualize larger data sets, where we're not dependent on the number of venues in the data set, or the number of papers, or number of people, and so we can handle more types of data sets in this way. And we found that the LDA topic models do exhibit good similarity to documents, so that seems to be a reasonable way to come up with these topics. In the future, we'd like to look at applying our work to other display form factors. And one of the more difficult ones might be trying to extend to larger displays where people would be tempted to be able to handle more topics than you can display on a smaller display. But if you have more topics, then there's less support for each of the topics, and you might end up with junk topics. In our paper, we mentioned a way for handling those junk topics. And finally, the other thing that we'd like to do is LDA right now only is dealing with single terms, and we'd like to be able to handle phrases. And so that's another area to look into in the future. Thank you.
Peter is approaching the mic.
So I have two questions related to potentially the lack of user study. It looks like you have to get a user study to what extent people see that. As I think it's great approach and visualization and topic extraction. If you usability concerns, I wonder what you think about that, and because they have been implementing another system. First of all, you can't explore a set of topics statically because you use NDS. If you use, for example, dynamic thing like Vibe, you can really explore that relationship between topics and papers, because Vibe allows you to move things around, and that's kind of very useful. To what extent it might be value, I don't know. And the second related thing is clustering. Too many topics might overwhelm the users. In that case, visualization of graphs frequently do clustering. You can cluster a bunch of nodes and move them together. And since you have LDA, just the previous paper tells us could be hierarchical topics, right? What do you think about these two things? Do you feel that they might increase the usability of what approach you're using?
I might answer the first question. So I think, I think actually with the systems I'm working with our colleagues, it's more like this is like one view to the data, whereas some of the older systems like Vibe and some of the commercial systems, they have many, many views, right? So I think this could provide a certain view to the data, that's all. And it's not supposed to be completely show you what to, yeah.
And what do you think about clustering and hierarchical topic modeling?
That's an interesting idea, and we have talked about it, but we haven't quite figured out how to deal with it in a user interface. Would people be then moving down through the hierarchy? And this seemed like an easy way to do it, because one of the problems I think also with a hierarchy is as you go down in the hierarchy, you have less and less support. So it depends on how much data you have where it would be applicable. But yes, that's an interesting idea. I agree.
Thank you very much. Let's thank the speakers again. And on to rank as you go, user-driven exploration of search results, presented by Cecilia Di Sciascio from No Center. No Center? No, I'm sorry, my English pronunciation is not always no. How do you say it? Can you, Peter, help me. How do you?
Oh.
No, I don't know. I don't know. There you go.
Pronounce what, sir?
Sorry?
How do you pronounce?
No Center.
No Santa.
Just No Center.
No Santa. This popped up.
You need help?
It came up. But that's the name.
But you seem to be connected already.
Yeah. Ah, both sides. Okay. I thought I needed this one too.
Yep.
Oh, could be. Yeah, that's Spotify. Crazy. Yeah. It's still playing? Jeez.
Thank you for the music.
I think it was quite fun. Okay, so my name is Cecilia Di Sciascio, and I'm working on my PhD at No Center, and I developed this work along with Vedran Saul and my PI, Eduardo Beas. So, searching and collecting information occupy a large portion of our daily productive time. Now, as Maslow stated in his classic hierarchy of needs theory, After we have fulfilled our basic and physiological needs, we seek to fulfill other social and psychological needs, and they tend to go towards informational needs. So we search for information in a variety of scenarios, like on the web, on our file systems, or using dedicated apps to scan our bibliography. And in this context, information retrieval and recommending systems have become the preferred means to obtain new information. And now in the era of big data, we get loads of content cheap and instantly, in no time. But how do we deal with this from the human point of view? Like, how can we quickly discriminate what is relevant from what is not? And as it has been mentioned several times today, it's often that we fall in the information overload problem when the user gets so much information that it's overwhelmingly hard to deal with it, and the user no longer knows how to filter out what is not important. So that's where information retrieval and recommended systems meet human-computer interaction. So Mark Canini defines two types of search strategies. On one hand, analytical, and on the other hand, browsing strategies. So analytical search strategies rely mostly on carefully planned queries and that require precise syntax. And on the other hand, browsing search strategies rely mostly on on-the-fly selections, navigation, and trial and error actions. And the trend today is shifted towards a more active engagement of the user in the search process, in which Contact the Web is a platform that has legitimized these browsing strategies, supported by interactions through the view. And the work we present today is really focused on browsing search strategies. And to do so, we developed a web-based tool that aims at supporting the user while searching over a collection of documents. So our approach is basically a highly interactive user interface where we emphasize aspects like controllability and transparency, and to some extent predictability. And we named it uRank because of its user-driven nature. And our approach is a combination of visual and text analytic, well-known text analytic methods. Regarding the text analytics we use, we received a set of documents, and right now we're working with titles and abstracts. Eventually it could be extended to full documents. So we grab all the documents and then perform some tokenization, then a parts of speech tagging, so we can filter out everything that is not a noun or frequent adjectives. Then there are singularized, lowercase, cluster using stemming, and then TF-IDF is used for a weighting scheme. And as a result, we have, on one hand, document vectors composed by the meaningful terms, and a sort of bag of words with terms contained in the whole document collection. When we look at the user interface, this is how the latest version looks like. We have a component called the tag box, where we place all the collection keywords, a query box where the user can express their information needs in terms of these keyword tags, and a ranking view that presents an augmented list with tag bars that convey document relevance with respect to the keywords that the user placed in the query box. Clicking on one single item on the list displays a document viewer with the entire with the content of the document as a model. And here we follow Colin Ware's advice, like use strong pre-attentive cues before weak ones, where ease of search is critical. That's why we use color-coded keywords for so they pop out from their surroundings. And this is basically an overview of how this approach works, but I think it's better if I go to video and then. So this is how the interface looks initially. The user can explore the keywords contained in the collection. By hovering on a tag, additional information is displayed, which refers to of how many documents contain the keywords and to which other keywords this one is related. And clicking on a keyword shows the other keywords that appear in proximity. Okay. Keywords can be either dragged and dropped individually. Or in a multiple drag and drop. Yes, okay. Okay, so summarizing the approach, we receive a list of documents. We automatically extract the keywords and extend the documents with document vectors. And the collection keywords populate the tag box. Then the user dynamically can choose the preferred keywords, and the ranking view displays the list reorganized. Summarizing the interactions, we have exploration features by hovering on keyword tags, and by clicking on them, the ranking on the fly mechanism that provides controllability so that the user can either add tags, change their weights, or delete them to modify the document rankings. And we provide transparency by representing with stacked bars the recommendation rank, the document ranking. We represent the overall score. That's the width of the entire stack bar, and individual color-coded bars represent the contribution of each keyword, as we can see here. So we performed 2 user studies for reasons of time. I will try to be very brief. The first one was a comparative user study. We compare uRank against a list-based user interface, like something the Google-like one. It was a 2x2 within subject design with 2 independent variables and 2 levels. We had tool using uRank or the list user interface, and either 30 or 60 items. And we chose 4 topics to randomize them. We had 24 participants in total, and the main task goal was always to find the 5 most relevant documents for a given text. And within each task, there were 3 subtasks. 2 of them were about finding relevant documents for 2 or 3 keywords, and the third one was about finding relevant documents for a longer piece of text. At the end of the study, they had to complete an ASA/TLX form for subjective workload feedback. So we analyzed workload on one hand, and the results showed that all workload dimensions had a significant lower values for uRank. When we analyzed completion time, we noticed that participants actually tended to take a slightly bit longer with uRank, although the difference was not significant. But when we look at workload dimensions, and particularly the temporal demand, we can see that participants felt more relaxed and confident with uRank overall, despite no differences in completion time. And this study had some limitations, like, for example, users were not working with topics that they were expert at. We chose them for them randomly. And also they had very strict tasks to perform. So then we performed a second one, where besides letting them do some free exploration with uRank, we were also interested in doing some action and search strategy analysis. So the task here was to bookmark interesting documents for a chosen topic, and then we collected action logs and subjective feedback. We had in total 16 participants. So this table summarizes more or less the results. We can see that users extensively explored by a tag hovering, meaning that the informative tooltip was useful. Every user performed on average around 10 ranking updates per session, and of which simple tag drops were the most frequent updating actions. Multiple tag drops were scarce. Even though people reported understanding how the mechanism worked, they mostly dragged keywords one by one. And weight changes were almost as frequent as single tag drops. Tag deletions were at most done once per user. And looking at the average number of bookmarks, we see it was around 4.5, which is not discouraging because we suggested bookmarking around 5. So, however, we don't know why 4 of the participants did not perform any bookmarks. So if we average over the 12 participants that did, the number of bookmarks is roughly about 6. And when we split the ranking update actions, we see that most of them happened before the event of the first bookmark action, which suggests that the participants mostly refined their interest, the search interest, and once they were more or less sure about the ranking, then they bookmarked and up to the last one. That can be corroborated by the plot on the right bottom. So, moving to the conclusions from study 1, we can learn that participants found it significantly more relaxing to work with uRank in comparison to a list-based user interface, despite no important differences in performance or speed. And from study 2, we can learn that the majority of interactions were found useful, and that uRank has the potential to engage participants in exploration. And I say potentially because I think we need a larger longitudinal user study to actually know whether they engage or not. The average session time was around 5 minutes, so that's not long enough to tell whether they really engaged. And our future work is going in the direction of developing a more intuitive multiple drag and drop mechanism, an overview component for navigating large lists, an alternative visualization for tag box that is a landscape actually, extended text mining methods by enriching keywords with synonyms and semantic relationships, and working on a social recommender system that is being tested with the bookmark logs collected during these 2 studies. Okay. Thank you for your attention.
Have a question before the final paper. So I have a question. You have, especially in the second study, you do a much more detailed analysis of how the people actually use the system.
Yes.
And I would be interested to know your perception of how the element in the interface on the right, where you can explore how keywords connect to each other, was used to get ideas on to which extent it was used to add the keywords in the, let's say, filtering or search.
If we go back to this table, okay, they mostly did hovering, and actually around 2 times they clicked on the keywords to get this information about co-occurring keywords. So that means that they were more interested in getting the quick information from the tooltip rather than digging into more complex relationships with keywords. That was actually what we wanted, but did not happen in this study. So that's why we're aiming for a longitudinal study to see if that actually serves in the end.
Thank you. No more questions? If not, then let's, yes? Everything was very clear. Thank you, Cecilia. So let's go to the last paper. Thank you very much again. So last paper, it's from the TIS journal. So I remind the Evangelos, the author, that he has 7 or 8 minutes for the presentation, and the presentation is about exploratory visual analytics and interactive pattern extraction from semi-structured data. And presenting is Evangelos Milios from Dalhousie University.
Okay, that's excellent.
Okay, my name is Evangelos Milios from Dalhousie University in Halifax, Nova Scotia. This is a short presentation on a long paper that appeared in the ACM Transactions on interactive intelligence systems. So this is about semi-structured data. And what is semi-structured data? It's unstructured text data that comes with metadata. This is an example of online reviews. Okay, so here you see the text, the free text of the reviews, and then you see metadata like the user rating or the date or the source. The problem that motivated this work is the analysis of aircraft incident reports. Every incident that happens to an aircraft gets recorded by the airline and shared with the aircraft manufacturer. And these aircraft incident reports, they are semi-structured data. They have free text describing what happened, and they have metadata like the date, the airport, the phase of the flight, and the time of the incident. So safety analysts need to make sense of this data in order to improve the safety of flights. And what they typically do is analyze the free text, and they try to connect it with metadata fields. For example, a safety analyst might be looking into whether there are any incidents correlated with any time of the day, or more specifically, if wake turbulence accidents or incidents are more likely to happen in some airports than others. So VitaSSD is the system that we propose for performing this type of analysis on semi-structured documents. The objectives include exploratory visual analysis for the data that allows the user to identify patterns by joining the free text, the unstructured component of the incident report, and the metadata. So the system provides the ability to cluster and visualize free text documents that facilitate exploration, summarizes the clusters with meaningful keywords, finds unexpected patterns between the free text and the metadata, and keeps track of the user actions for provenance and backtracking if the user wants to. The users can provide feedback on how data should be clustered, so interactive clustering, and are able to explore and test hypotheses or patterns and make annotations on the data. The system is designed so that it can be applied to very large collections, like hundreds of thousands of documents. This is a view of the dashboard of VitaSSD, which consists of several panels. They're all coordinated panels. We're going to focus on the top two. Okay, so two methods that we use here. One is dimensionality reduction, and methods for supporting document exploration. We have a new method that is embedded in this system based on deep networks for dimensionality reduction down to 2 dimensions. And what you see there is a scatter plot based on this low dimensionality. The user interacts with the system by selecting or unselecting documents to base the analysis on, performs interactive clustering and document exploration by operating on the low dimensional space, which allows for fast processing speed. And we also have smart sampling of the documents to visualize. And this improves, of course, the rendering speed and avoids visual clutter on the display. So metadata analysis shows patterns between the structured and unstructured components of the data, and we determine that by using an independence test, and we can determine interactions between the values of the metadata and given clusters or given selections of documents. So in this figure, for example, you see a significant pattern between cluster 1 and 2014 and cluster 5 and year 2008. So how does the supervised clustering work? Okay, the user is now focused on this wake turbulence result and sees that in cluster 2 there are documents about this type of incident. Okay, the user performs a search on wake and finds in the second dashboard that the second pane that what happens there is that there are wake documents that are spread in other clusters. So for this, the user will indicate that wake, the word wake should take higher weight in the clustering, okay? And now that makes cluster 2 more concentrated around wake turbulence, and at the same time, if the weight of this term increases, it manages to focus more cluster 2 on turbulence and not disrupt the other types of wake that have to do with pilot fatigue. So in the paper, we're going to see the details of the entire system and several user studies, and there are 3 videos that you can watch that are associated with the journal publication. And I will also like to acknowledge Axel Soto, who is the and implementer and evaluator of the system, my colleague Vlado Kessel, and an undergraduate student, well, back at that time, who contributed the dimensionality reduction method, Ryan Kiros. Thank you.
So, do we have some questions? If not, I have a question. I know you did not have time to go into the user studies, but could you extract out of these several studies that are in the paper, in particular what regards this multi-pane approach of the user interface, and you have several components of,
Yep.
In which way the users struggled or exploited these multiple different panes?
Well, the remaining panes, which I didn't have time, of course, to discuss here, they focus on the visualization of different aspects of the clustering, documents and clusters. Okay, it is a complex system, no denial of this. Users needed some training before they were able to effectively use it. Okay, but we're dealing with a task that is in itself complex, which is sense-making of document collections. It is neither search nor browsing. It's something in between. Okay, and this is exactly what safety analysts, who are not experts in data mining or text mining, they need to accomplish.
Thank you very much. So, are there more questions? If not, I will ask everybody to sit down for a moment, and we thank Evangelios. Thank you very much.
Thank you.
I'd like to ask everybody to just stay put for a second while especially the poster authors, move to that area, and they will be coming in to do a big show for us. So I think if you're all already out, remember to go. If you're not already out, go, as you're a poster author, go to the corridor over there. Everybody else, just a moment of patience, and then you get a very nice, compact preview.
Okay. Yeah. Welcome to the medley session. If you're not familiar with the medley session is a series of a quick talk. It's only like 45 seconds per each. So you will see all the overviews of posters and demos. It's going to be about 30 minutes, but it should be fun. Let's get started.
Hello everyone. My research topic, the goal of my research is to build interactive decision support systems. When we want to select one candidate from many alternatives, we sometimes have only fuzzy understanding of what we want. So in such situations, the system can estimate our selection criteria from gaze behaviors and estimate and proactively support is helpful. But sometimes our selection criteria can be changed over time, such as adding a constraint. So the question is how to trace the temporal change of our selection criteria. And our approach is to adapt statistical tests to detect the distinct browsing behaviors for multi-time scales. Thank you.
Hi, I'm Genta Suzuki from Fujitsu Laboratories, and we introduced a hand image projection system for running manual work. And our system records motions of experts and project them onto a work object like this. And our system projects a hand at real size and maintains the relative position to the work object like this. And we also show the results of the user study. The user study participant worked tasks after watching expert video in 2 ways, using our system and using a display, and we compare the work time and errors and user ratings of the tasks. Thank you.
Not me.
Yeah, so in this one, there's a lot of transformations and a monitor. Oh, and Batman. Batman and a lumberjack. Oh. Ooh. It got rearranged because it was a mobile device. That's good. Yeah, Adobe.
Hi. Okay. So, do you believe that greater awareness of data leads to better behavior? If so, wouldn't weight scales have made a dent in our obesity epidemic? How about a scarcity mindset, having less of something than what you feel you need? We wondered if we could use personal data to channel the scarcity response toward improved wellness. So we designed an information interface, which we call it the LifeWord. The LifeWord primes time scarcity, the quantity of time we have available in life, and it also primes opportunity scarcity, the quality of activities we can spend this limited time on. So come and visit our poster to learn about our experience of using the LifeWord. Thanks.
Agent teaming and agent transparency. The situational awareness-based agent transparency model provides a framework of information requirements for supporting the operator's situational awareness while interacting with an autonomous agent. Level 1 provides information about the current status of the agent based on its plans and actions. Level 2 provides information about the agent's reasoning behind its actions, goals, and projections. Level 3 provides information about the agent's projections of future outcomes and uncertainty associated with this level or previous levels of information. When combined, all 3 levels of SAT-based information can aid the operator in maintaining accurate situational awareness of an autonomous agent, such as the autonomous squad member. Please visit us at the poster to find out more information about this project.
Hey, I'm Robert Pianta on behalf of Georgia Tech and some of our friends at the ACES Lab, which is an Advanced Computational Electrical Systems group. And we created a spatiotemporal exploration tool to look at dynamic changes in the power grid with modern renewable energy sources being highly variant to things like weather and wind or solar. And we basically leverage color and volume to very quickly give an analyst an idea of the system state and allow for simple filtering and exploration. So if you have any questions about this, it can be used on other types of data. Come by our poster shortly. Thank you.
Hi. What I'm talking here is about error correction of eye movement when reading a text. The important thing is a mapping between each fixation point and the word in the text. This is a typical example of eye movement measured on eye tracker. So you see, it is difficult to know where do you look at accurately at the current tracking environment. So in order to analyze reading behavior, it is important to know the position the user actually looks at. Today we propose an automatic mapping approach, and I will show the detailed implementation as well as experiment later. Thank you.
So our poster looks at enhancing interactivity using transcranial direct current stimulation. TDCS is a form of a non-invasive neurostimulator. It's basically a device you wear on your head, and it passes electric current to your brain to enhance your working memory and task load engagement. Okay, so that's what we do with this device, and we look at how to use it for interactivity. Thank you.
I'm sorry, what? Oh, I can help you with the homework.
So this looks like a technology can help a deaf person to communicate with a stranger, right? But can you imagine this for everyday family conversations? In America, 96% of deaf children actually born to hearing parents. So come to our poster if you want to learn more about how technology can help families with deaf children to learn sign language together.
Hello everyone. Imagine a world where technology is everywhere assisting people in their daily activities, especially in educational settings where instructors and students, they talk and collaborate with each other with the help of many different electronic devices, such as electronic whiteboards, laptops, and tablets. But wait, this is already happening, right? That's what we call ubiquitous learning environments. So why not use it to simplify the creation of educational content by instructors and leverage the teaching learning process? So if I will tell you how, if you stop by the poster. Thank you.
Hello, my name is Gerardo Mendizabal. Modern equipment for medical image analysis. Was too fast. Modern equipment for medical image analysis are able to deliver volumetric data that is very important for diagnosis, but unfortunately, exploring this data is very difficult because there are many parameters that has to be adjusted, and therefore, medical doctors have to be excessively trained to explore this data. So we believe that any doctor should be able to deal with this data, and we propose tools for the natural and intuitive exploration of the volumetric data. And for this, we map the volume in the computer to a real world space. So we are able to interact with this volume by just moving some surface in the real world space. So if you're interested in this, please come and visit us. We're poster 11. Thanks.
Hi,
In megacities like Tokyo, various events such as disasters, accidents, and public gathering occur every day. These events vary in area, duration, and impact. A key challenge here is understanding these ever-changing events as they happen all over a city for purposes of urban planning, traffic management, and disaster response. In this work, we propose a method of visualizing spatio-temporal events by multi-layered geolocational word cloud representation from an automatically geolocated microblog stream. Thank you.
In exploratory search, users' search interests tend to change quite often. It would be beneficial if the user would be able to adjust her old feedback easily when this happens. We present a timeline interface that visualizes the user's feedback history to the user, shown here at the bottom. The user can see all of her past feedback with a single look and make changes if needed. In addition, we estimate the accuracy of each individual user feedback using a Bayesian user model and highlight feedback with low accuracy directly to the user so that the user can find the outlying feedback easily. There will be a live demo at the poster. Thanks.
Hello, has it happened to you to take a recipe and after preparing the meal to realize it didn't come out the way you were expecting, or after following some instructions to realize the piece of furniture you just assembled needs to be reassembled? If you are one of those people, join me at my poster where I will be talking about how can we learn computational models of human behavior from textual instructions such as recipes or manuals, and how can we use these models to perform sensor-based activity recognition in order to assist the user in his daily activities. Thank you.
Hello, my name is Artur Arsenio. The world population is aging, so together with a student of mine, Luis Salvado, we developed a wireless, non-invasive system for not only monitoring elderly people and athletes, but also to provide corrective feedback. We tested 3 different technologies, inertial, opticals, and flexible technologies, in order to feed 3 different controllers, and the information from the motor controllers are then used to create temporal and spatial patterns, actuation patterns that, according to the target user behavior, are used to provide the necessary feedback. Thank you.
That was poster. Now we're going to demo. You need a voice.
I remove the voice. So, hi everyone. As you probably know, newspapers often use creative headlines based on modification of famous expressions. For example, here we see Saving Private Ryan, The Dark Side of the Moon, and finally, This Little Light of Mine. Of course, coming up with a good title is not easy, so we have created an interface for a natural language processing system that assists user in every step of this creative task, from keyword identification down to the final title. And if you want to see how the demo works, come and find me and you can interact with it.
Hello, my name is Richard, and I'm going to demo a prototype of an interface for drum rhythm variation. In electronic dance music, drum tracks are often created note by note in a piano roll editor, as you can see up here. And this can be a really cumbersome and time-consuming task. So what we did, we created a tool that allows the user to enter a basic drum pattern in a step sequencer-like interface, and which then creates variations of this pattern using an artificial neural network. And these patterns can then be used for music production or live performance. So it's really fun and easy, and I invite you to my poster and my demo to try it. Thanks.
Okay, hi everyone. My name is Kuldeep. I'm just standing in for the authors. So what I'll be presenting is the a easy navigation tool which can make your life easy for educational videos browsing. So humans are pretty adept in navigating through the textbooks. They frequently use table of content, table of figures, and all of those things. We have built a similar mechanism for long educational videos where you get a table of content which is sourced from combining visual information, audio information, as well as external sources like Wikipedia. So hope to see you in my demo. Thank you.
Oops. Sorry. Oh, yeah. No, it's yeah.
This is yours?
No, it's right after that. Yeah, or a little bit earlier. All right. Okay. Cool. So hi. The iMotion system is an award-winning, large-scale interactive video search engine that features some unusual query modes. So Query by Sketch is a content-based retrieval method that allows retrieving images that are similar in color, and our system also features semantic retrieval mode based on sketches. Thank you.
Hi. Digital footprints can be used to detect. Sorry. Yes. I'm sorry, but I want. Can you do the very first one? Okay. Sorry. Digital footprints can be used to detect people's personality. So people have different personality. They may be curious, they may be adventurous, or as agreeable as this gentleman. So, are you curious about yourself? Or how about comparing yourself with this gentleman? So we are building an app for you. And so we call the Scope G. In this app, you can interactively explore your personality profile and compare your profile with others. So if you are interested, please stop by the poster session, check the demo number 6. So see you there.
Okay, so you probably already know what TagFlip is. Let's just have a video here. Current songs tags on the left, next songs on the right. I'm just here to tell you that we do have this on a phone, and if you're interested in playing around with it, come visit the demo session. Let's just watch the video. Is it not playing? Oh yeah, it's fine. Put the sound.
Hello everyone, my name is Pedram and I actually presented our paper Interactive Intent Model from Multiple Feedback Domains. So the problem that we are dealing with is how a system can learn user intent in a human-computer interaction scenario. So there's a user on one side with a hidden intent and there's a system. And based on the user feedback to the system wants to learn and guess the intent of the user. And how machines can solve this problem, of course, by solving a gambling problem, also known as multi-arm bandit problem. So if you're interested in the work, you can come to and visit the poster. Yeah, that's it.
In our research, we create and design a novel brain-computer interface combined with performing arts. We use the wearable EEG device to detect the audience engagement and also connect it with a virtual theater. The virtual theater will display content-related performing cues to increase the audience engagement. So in general, our work was intended to help the stage designer to improve the design of live performance from the audience perspective. Thank you.
Hello everyone, this work is Scepter. It is a sign language recognition device. So as you can see in the device, we use wireless armbands to detect like standard American Sign Language words. The focus of the work is to make it extendable and also to make it wireless so that the adoption rate would increase. This can also be used with a cell phone, although it is being used with a computer. Yeah, so the screen on the back shows the sign that was performed. And it achieves okay, thank you.
Hello, my name is Tomoyasu Nakano from AIST Japan. Today I'm going to talk about Playlist Player, which is a user interface for sorting music playlist by 4 ways with 9 properties. These 9 properties are derived from content and web. They can be used as sorting criteria and can be integrated. For example, as shown at the bottom, Playlist Player can estimate female probabilities of vocal, and Playlist Player can sort a playlist by ascending order, descending order, random order, and smooth order. In addition, 2 or more properties can be integrated. Thank you.
Hi, everyone. Business analysts and data scientists often spend tons of time in writing programs to pre-process the data before really using the data. Recently, programming by example approach enables these users to transform this data without running any code. But the problem is that it's hard to verify whether all the data are transformed correctly. So we present an approach for helping the users to transform all the data correctly with minimal user effort. So welcome to our demo. Its number is 13, and we also have a presentation on Wednesday morning. Thank you.
Hi, I'm Masai. We developed a novel smart eyewear that can recognize the wearer's facial expression in daily setting, and it can be used for mental management or caring system for elderly people. And we use skin deformation and a large number of photoreflective sensors measure the distances between the various spots of the eyewear frame and the skin surface on face. And the advantages of usability in daily setting scenarios, and also a smart appearance and a low energy consumption. I'm going to talk more details on the Wednesday morning session. Thank you.
Hi, our demo is a recommender system for writing music. If you find yourself always using the same chords over and over again, or it's because we always hear a lot of songs that's kind of stuck in a common chord progression, this tool can give you recommendations about more adventurous things to try out. And these things will be similar and relevant to you because it's trying to figure out what's similar in the context of what you're trying to do. We learn a model from 200 rock songs, and it gives us kind of some semantics of the space. And when you're replacing your chords, because music has this temporal constraint, it's very sequential, you can't just like change one thing, but it has this effect of changing, you needing to change what's around it. So that's where the name Ripple comes from. Thank you.
Hi, I'm Nick Davis, going to be talking about co-creative agents.
And so this, for example, okay, computer, let's draw a picture together. So it might seem strange to think about a computer as a collaborative partner, but advances in artificial intelligence and computational creativity are actually beginning to make this a reality. But what exactly is collaboration, and how do we do it effectively? Further, how do we make an intelligent agent that's able to improvise, adapt, and coordinate with a human user in real time, given the wide range of creativity? So I'll be demonstrating our prototype co-creative drawing agent called the Drawing Apprentice that will interact with you in real time, and you can help teach it how to draw. So come by and help us, give us some data and help this little guy learn how to draw.
Hi, let me show you a short scenario of a dental surgery.
This dentist has a really steady hand, and I feel no pain.
Oh dear, would I supposed to use the number 14 drill? I need to check something. I will be right back.
Damn! The drilling head is too big. The tooth is now fractured.
Get me out of here!
As you see, physical skill is important. Decision-making skill is more important. How can we teach decision-making skill? Come to see my demo and my talk on this Wednesday afternoon. Thank you.
So the paper we're presenting, basically we've developed a search system for sport. So the example I have here is that we have Steve Nash, he passes around his back, there's a three-point shot. So how can we actually search for that? So currently we just use keywords, so we can say three-point shot, click retrieve, and we can find everything like that. But the problem with this is that words aren't very descriptive. We get no ranking, and basically a picture tells 1,000 words. So instead of using keywords, we basically want to use a chalkboard. So people in sport understand X's and O's. How about let's just use that? So that's basically our system. So we can use examples, you can draw on it, and we can find all the plays like it. So if you're interested, come see a demo or a paper on Wednesday. Thanks.
Hi, my name is Pavel Samsonov. I'm a PhD student in Hasselt University in Belgium, and my thesis topic is improving special context-aware services. You may ask yourself, what is still left to improve? Prominent example of context-aware services are Google Now, Apple Siri, or Microsoft Cortana. They are able to process several requests, such as how to do a presentation, or directions to Brussels airport, as well as where is the next coffee shop. But however, there are some requests that are unable to process at the moment. If you want to go more, please come to my presentation on Tuesday, to my demo, and to my poster today. Thank you very much.
Hi, I'm going to present the visual text analytics for online conversations. So if you have noticed my previous talk, you have already know this use case scenario that iPhone bending went viral when the iPhone was released in 2014. And John was curious to explore whether this bending issue is really serious or not. So he wanted to explore this set of conversations. If you are also curious, just like John, and want to verify for yourself, come to my demo session and check out for yourself whether this bending issue was really serious or not. Okay? I will be looking forward to your feedback. Thank you.
Hello everyone, my name is Alexandru Lemes and I'm working for the Heraclea Laboratory. Our goal in this lab is we are actually researching the aspects for stroke patients, which is the leading, stroke is actually the leading, fourth leading cause of death in the United States. And in our research, what we try to do, we try to provide rehabilitation services to the patient, And in this research, I'm focusing how to assess correctly and to provide physical and cognitive therapy with state-of-the-art tools. So for this reason, we are using a robotic manipulator, Kinect cameras, depth cameras, and also in adaptive user interfaces like games in order to assess and provide services. Thank you.
Hi, everyone. So who here likes to play video games? What if you could actually learn something tangible by playing a game? Could it actually be fun? So stop by my poster and try it out for yourself to find out.
Hello everyone, my name is Iftikhar
This
Tanvir.
is a fast-forward video of a person talking. This is a common pattern of his body movements. These are the places where those patterns appeared. Presenting AutoManner, an automated interface for making public speakers aware of their mannerisms. The interface is fully automatic. No human behind the curtain, no artificial AI. This is my PhD advisor's video. AutoManner paper presentation in Wednesday, 2:30 p.m. Visit hci.cs.rochester.edu.
And see my demo today.
Hi, in my poster I'm arguing that interactive reinforcement learning can be utilized to facilitate safe adaptation of interactive learning agents. Interactive learning agents interact with their environment and learn through the interaction. And basically we're focusing on HCI applications such as robot-aided training and rehabilitation, that also we have a secondary user that can supervise and guide the interaction for safety. And basically the problem is how we will exploit human knowledge from both parties in order to facilitate safe adaptation, aiming at a tailored and personalized interaction. This is the proposed framework. If you want to learn more, please come by my poster.
Hi, I'm Yu Chen from University of St. Andrews. So let's have a look at how many steps does it take to preserve my privacy before I share my location in the pub. So first I need to click on the friend button and then more options, then custom, then to specify all the groups I want to share with and all the groups I want to have from. So every time I share a location, I need to do these steps. So to avoid such a hassle, I propose to use recommender system to do it for us. And we've also done user study to investigate the user's acceptance of such recommender system. So if you are interested in our results, come to my poster session and my talk tomorrow afternoon. Thank you.
Hi everyone, my name is Sean. I'm a grad student at UC Santa Cruz, and I am working on a context-aware cognitive testing system for use by the elderly population. The idea is to use mobile sensors to understand contextual ambient factors and how they play a role in testing efficacy in order to better aid in psychoanalysis. So if you're interested in my topic, please come see me at my poster. Thank you.
Hi, I'm Ming Kun from UIUC. This is a picture of Donald Trump. He's a very controversial topic on Reddit. Some people support him, and some people oppose him. However, Reddit won't tell us which group of people and why they have such opinions. In addition, Reddit cannot capture other people's reactions to these online social opinions for some controversial topics, such as Donald Trump. So we propose a new mechanism and are trying to build a new interface to solve the problem. I will give a talk at the Student Consortium. Please come to my talk. Thank you.
Hi, my name is Vijay Rajana from Texas A&M University. This is my work. So have you ever wondered how to achieve precise point-and-click interactions in a gaze-assisted environment? What solutions exist other than dwell and blink-based solutions for accurate gaze-assisted interactions? Also, how to facilitate selection of small targets without modifying the interface itself? In this work, we present a framework which integrates foot and eye tracking to achieve accurate and effective gaze-assisted interaction system. Furthermore, we discuss the implications of such a framework for other applications like tabletop interactions, gaze-assisted authentication, gaze-assisted typing. If you'd like to know more about my work, come and talk to me at the poster session. Thank you.
I'm the last one. No, flash a slide. MOOCs. It's a great thing, right? Great faculty teaching great talks for free. What is the major trouble with MOOC? Anyone knows? Everyone said it. The major trouble, no. Major trouble is engagement, right? Typically 5 to 10% people finish the MOOC. They lose the interest, they're not motivated to work with MOOC. Well, it's great if it's for free. It's a major trouble with educational content in general, especially free content when you don't get a point. How to get students working on something which is greatly beneficial for them, but, well, they don't get any salary for that. So we have some tools which allow to do that. So we can increase student engagement in the free, no points content several times. No slides, you don't know how it's going, come to the presentation.
All right, let's thank all of our poster, demo, and student consortium speakers. All right, so we have roughly a 23-minute break until the post-demo and poster session. It is actually sunny outside, so you may want to go experience that while it's still here. The demo and poster session, as we said before, stone room, go out the lobby, look to your right, there's a building made of stone, that's where it is.